Well, hi. Welcome to Eric's Electronics, and today we're going to talk about a dim bulb tester. Welcome also to the reality of the pandemic. I think at this filming we're about, at least 2 months in, and it's been an interesting experience, I'm sure, for all of you. It'd be interesting to know if you want to leave comments about any electronics projects that you happen to be doing during this time, when maybe some of you have a lot more time than you used to, and so you're doing some more things. So let's get on to today. Today we're going to talk about a dim bulb tester. Why is it useful? What does it do? How does it work? A little bit. And then I will show you the build. It won't be in any great detail. Really what I did was I just started with the basic design with stuff that I already had around the house. I used a 2x4 to kind of mount everything on it, which was a piece of scrap lumber. I had a couple of electrical boxes and things like that. So I just started working on it. And then as I realized, oh, hey, it'd be good if I had this feature or that feature, then I had to go over to the hardware store and actually buy some of those supplies. So I'm very comfortable working around electricity, around house voltages. I've done a lot of electrical work, and for me this is very, very comfortable sort of stuff. If you are not comfortable, if you don't know what you're doing, again, you assume these projects at your own risk. I really need to encourage you to get smart on these things. Start with small steps and then work your way up to the more advanced stuff. So this, as it turns out, is a pretty simple sort of project, and we'll go through what it is about. This is a very simple sort of testing equipment, and the equipment is so simple that most people who use one just make their own. It's that easy. So I'm going to kind of talk you through what it does, the schematic that I'm going to use, and then you'll watch me make it. The only thing missing will be Benny Hill music. You'll see that when we get there. All right, so let's go in and start talking about what a dim bulb tester is. So a simple current limiter looks like this. You have the plug-in to your line or your mains here. The hot lead comes up here, goes through a light bulb, comes out here to the load, the outlet. The neutral just is carried over. This is a current limiter, and you put the light on the hot side of the circuit. Now, what does the light do? Here's the reveal. The wattage of the light is important. You need to use an incandescent bulb so you get a particular wattage. Don't use LEDs. They're not going to use up enough power. The load is over here. Here's your radio. In our case, that's what I'm building this for. It's particularly that radio project. And so you plug the radio into the outlet here. You plug the plug here into the normal thing, and if there is a short in the radio, then the bulb lights up quickly. You can disconnect the radio, and then you will have protected anything from potentially burning out or becoming more damaged, as we mentioned before. Now, how are the light and what's being tested, how are they related? Well, here's the deal. Look, it's math. If you consider the load to be Y, here's the wattage in Y, then the wattage of the bulb, that's going to be X, is going to be twice the wattage of the thing being tested. So, in the case of the radio, if it's 18 watts, then you want to find something that's between about 1.5 to 2 times the wattage of what's ever being on the load here. So in this case, you'll need to find something that's about 25 to 40 watts here in the bulb. So you need to put a 40 watt bulb in here, put the load here, and then what will happen is that if the radio is okay, then the light will light dimly. That means it's okay. If there's a problem, the light will light brightly, and that's how you know. So again, the ratio is about 1.5 to 2 of what the load is. 18 watts here, 36 watts here, So probably closer to 40 would be more than enough. Okay? So here's the next modification that you can make. So a lot of people just make the current limiter looking like this. But let's make a modification, okay? Let's put two lights in parallel. Now we can kind of control. So we can go anything from 200 watts here by using two 100 watt bulbs down to 30 watts with two 15 watt bulbs, or down to 15 watts with just one 15 watt bulb here. The idea is that you can mix and match. The same thing holds, right? Put that on the hot side and then let the neutral come around, okay? It will start getting bright potentially here, but that's what you want to do. The two lights give the option to vary the current limitation that you're trying to put here, okay? So what's your next modification? Well, it feels pretty obvious to me. The next modification is to actually put a switch in here. Why do you want to put a switch on the tester? Again, you put the switch on the hot side. You put the switch on the tester because it allows you to better control the test and keep your hands off of the thing being tested. If there's a problem over on the thing being tested, you don't want to be turning it off over there. You want to be turning it off over here, right? You don't want your hands, you don't want any part of your body over here. You want to be over here where you can control that. So you put the switch over here to help you control the test. All right, so let's make another modification. Now, put a switch over here, which is going to be the bypass. So we put the switch that we turn on and off the unit. We have the lights here, and then we have a switch that allows the current to come through just directly without any limitation, okay? So we turn the switch off to test it, turn it on to kind of use it as routine, normal performance, all right? So it's a bypass. We don't put any limit on the load. Now hold on here. What about the ground? Well, the ground pretty much works exactly like the neutral. You just bring the neutral around, you bring the ground around. Again, in an American plug, the neutral is going to be the longer slot, the hot is going to be the shorter slot, and the ground looks like, I always thought this looked like some sort of despondent sort of face. These look so sad. Anyway, okay. So, we've got a switch to kind of energize the whole system. We have a switch to control whether the unit is going to be under test or not. It's going to be, this will just be a bypass, and it'll look just like a direct, basically a big old extension cord, right? So then, what's the next modification? Well, the next modification is this. Well, I put in a meter and a light bulb. So, when the switch is on, then the light, so once you have it plugged in, it's going to light up to show that it is, in fact, energized. And then you have the switch here, you have, and then you have a meter over here. So what are the light and meters for? Basically, light 3 shows that the unit is being energized. You want to look at the voltage to see what kind of load is going on. So you have a meter there, and you look at the current meter to kind of see what the current flow is. But the real reason, what's the real reason to put in the lights and the meters? Because, come on, you can't have too many lights and dials. Come on, that's just obvious, right? Okay, so we put in a light, we put in some dials over there, and then finally we have the unit as I designed it. We have the line in, we have a hot, we have a switch to energize the system, we have two light bulbs here which we can change or mix and match. We have the switch that will allow us to bypass or not. We have a voltmeter, we have an ammeter, and we have a light over here which will show that the so I moved the light from over here to over here because when I have the switch on, I want to be able to see that current flowing through here. And then finally we have the load and the equipment to be tested. Okay? So again, switch 1 is the unit on or off. Switch 2, on is no limit. Off, the limit goes into the test circuit. So the current comes through, lights up the lights, if there's going to be a draw, and the load here again, if the load goes short, if it goes short here, then this will just look like a very, very bright bulb. So you have, potentially I have two 60-watt bulbs, so we're going to have 120-watt. Well, it's going to get bright, right? If it's not, if it's okay, then the bulbs will shine dimly. Alright, so here's the dim bulb tester. Here's my cord. The cord is going to plug into, in my lab, it's going to plug into this variac over here, okay? The variac is off, the unit is off, we're under test over here, and then over here I'm going to put a load. The load I'm going to use is my soldering iron. The soldering iron, if you look at the label here at the back, the soldering iron is 60 watts. Okay, so with a soldering iron that's going to draw 60 watts, what is going to be the bulbs that I need to put in? Yeah, that's right, I need to put in two 60-watt bulbs. And so what we're going to do is we've got two 60-watt incandescent bulbs. So I plug that in. All right, so here we go. We're going to turn on the variac, turn it up to the normal voltage point. We turn on the unit. We're going to look at our voltage. Voltage is going to go ahead and climb up to 116. It's now under test, and now when I turn on the soldering iron station, we should start seeing something happening. Turn it on. Soldering iron turns on, and now you can see, can you see that the bulbs are glowing? They're glowing very dimly, okay? So now, that means that we're good. This is good. This is a good unit. There's no internal shorts. Everything is happily ever after. Turn this back off. Take that back out. Let's say that things were not so happily ever after. Let's say that we had a short. So we have a device, and here this is just a unit plug that is shorted out from here to here. So if I plug that in, yeah, I'll turn this off. Just for good. All right, we'll turn it off. Turn it back on. Clearly something's wrong, so we can turn that off. Okay. Now it's interesting, but here, if I touch this, there's no heat here. There's no heat at the cord. Why? Because it's just a light bulb. As a matter of fact, this was one of the comments that my wife made. She said, "Oh, look, you've invented the light bulb," which, I was really proud of what I had done here and everything. And she just, said it was a light bulb. And she's not wrong. So, let's turn that back off. Remove that. And that's what would happen if you had a short in the device that was being tested. You'd want to turn that off right away, and you'd want to then research why there's a short going on and fix that before you go any further. Turn the variac back down, turn it off, and that is a current limiter. Now, in terms of the build, eventually it'd be nice to put this on a piece of stained plywood, kind of steampunk it out a little bit more, use meters that were actual analog meters, kind of old school meters, things like that, all that kind of stuff. All that's great for a crafty sort of project, an artistic sort of project, but functionally, all the components are here. Okay? Again, what we're looking for is something that will protect the device under test from being shorted out and burned out and damaged before you know it. You don't want to wait to see smoke coming from the unit, because by that time the damage is being done. It has been done. So what you want is something that will give you a signal that you can react within human reaction time. So once you turn on the load, oh, bad things. 2 seconds, and the load, your device probably may have gotten overloaded a little bit, but it probably hasn't been damaged. Usually things that we make, consumer electronics, have some kind of overload protection. So all you need is just that second or two of reaction time to be able to turn off the unit and protect it. And that's the purpose of the current limiter. Bright bulb, bad. Dim bulb, good. Eventually, as I finished the project, the unit that you saw there eventually weighed in at just under 10 pounds. So it's a nice, substantial piece of project on the bench. And so, it's like my wife says, it's a really interesting light bulb. So I hope you enjoyed the presentation and learned a little bit more about what a dim bulb tester, a current limiter, is about. And again, if you like this, hit the like button down below. Even better if you want to subscribe. So there it is, a dim bulb tester, Eric's Electronics, another session done. Have a good day. Bye-bye.